Okay, now if the situation is like this, that means RL is constant, but XL is variable. You know from your previous experience, whenever the imaginary term is variable, okay, somehow again the variable in the sense you can put minus also, that is the idea. So somehow we'll try to make XL is equal to minus XS such that this JXS and JXL will cancel. Okay, when XL is variable, we'll try to make XL is equal to minus XS. That means XL plus XS is equal to 0. So finally the imaginary term will cancel. Okay, in such a way we'll vary this. Okay, then if the imaginary term is cancelling, then and again P maximum is equal to, under this condition, what is the current flowing? Okay, that RMS value will take then into RL. Okay, this is the maximum power transfer. And now we'll take some simple problems. We'll see what is the power transfer there. Find maximum power across ZL, maximum power across ZL. Okay, complex load impedance. And also, and again, you should know under what condition the maximum power will flow across ZL. Okay, then after that only you can find the maximum power. Okay, so first the circuit is like this. The ZL is connected here. ZL itself completely variable. Okay, that means both RL and XL is variable. Okay, so once and again, whenever you have a complex network, first you have to represent in terms of Thevenin. Okay, in order to apply the maximum power transfer theorem, okay, you have to represent the network first with the Thevenin's theorem. Okay, later you can apply the maximum power transfer theorem. J2, J1. Okay. So first the solution is, first you have to represent in terms of the Thevenin model. Okay, so what is Z Thevenin? Z Thevenin means remove the load, remove the effect of the sources. That means both are voltage source. So you have to make the short circuit. Okay, once if this is short, then these two resistance, okay, these two impedances will become parallel. Okay, that means 2 plus J2 parallel with 1 minus J1. Okay, so I will tell you one more trick. Okay, already you know that. So instead of finding the impedance, you just find out the admittance, individual admittance. Okay, because when the two admittance are in parallel, they can be directly added. Okay, so once if you represent in terms of admittance, okay, anyway impedance is there, but you can represent in terms of admittance. But if they are in admittance domain and the elements are in parallel, then they can add it. Then finally, if you want to the impedance, then you make 1 by y, then you will get the final answer. Okay, now here the final answer is 2 plus J2, or otherwise you can work out here also AB divided by A plus B formula. Both are okay. So only your answer has to be correct. But here if you see, just work it out, because here 2 plus J2 is there, here 1 minus J1 is there, but ultimately 2 plus J2 is coming. It's like this is something like infinite, because once if you do the parallel combination with infinite only, you'll get the same resistance. Okay, it's coming something like that. You just work it out. Okay, so whether you are getting this one or something else, if you are getting, what is the reason? Okay, just see. Okay, then okay, so now I know the Z Thevenin. Then what is V Thevenin? Okay, V Thevenin means I will remove the load. Okay, then I will find out the what is the voltage here, because this is the load terminal. I will find out the voltage here. So that means what, I can apply the KCL at this node. Okay, what is the current in this branch? What is the current in this branch? Because anyway this will be removed. Then based on that I will find out the V Thevenin. Okay, so once if you apply the V Thevenin minus 50 0 degree divided by 2 plus J2, and V Thevenin minus 20 30 degree divided by 1 minus J1 is equal to 0. So finally one equation, one variable. So final answer is 84.64 and 40.2 degree is the answer, V Thevenin. Okay, already you know what is Z Thevenin, but what should be our load impedance? Because when the load impedance is completely variable, then ZL should be Z Thevenin star. Okay, Z Thevenin star, because Okay, so what is Z Thevenin? 2 plus J2. Then what should be the value of ZL? Okay, that is 2 minus J2. Okay, so again you connect your V Thevenin here, 84.64, 42 degree, and Z Thevenin will come here. What is the value of Z Thevenin? 2 plus J2. Then this is 2 minus J2. Okay, 2 minus J2. Whenever you are in this format, you can directly use that formula, that V max is equal to V Thevenin square divided by 4 R Thevenin. Okay, but the V Thevenin has to be in RMS value. Okay, so make sure that it is in RMS. But sometimes what they are doing, okay, because when they give the problem like this, okay, they are not mentioning anything, either this is maximum or RMS value. But what notation we are following generally, if they give in this format, okay, they consider like this is already in RMS. Okay, but there will be some ambiguity actually, but they consider that this is already in RMS. Okay, if it is already in RMS, okay, then you can use that 50. Okay, so if this is already in RMS, both 50 and 20, then the answer that you got, V Thevenin, is also already in RMS. Okay, but there is some ambiguity is there. But if you consider like that, you can directly use. But anyway, they have to mention. Okay, so then if it is already in RMS, you can directly use this formula. Then finally you will get answer 895 watt. Okay, is the answer. Okay, so next question. Find max power to RL. Okay, now ZL is not there, only RL is there. This is 6 ohm, J8, 6 ohm. And again, here also you have to find out the Thevenin model. Okay, so what is the R Thevenin? You short circuit here, remove the load, then parallel of these two. Okay, parallel of, once if you take parallel of those two, both are same, then you will get off 3 plus J4. Okay, then you find out the V Thevenin. Okay, then V Thevenin is equal to 100, 0 degree. Okay, V Thevenin is equal to 100, 0 degree. You know R Thevenin and V Thevenin. Just to connect it. Okay, so this is already, and again R Thevenin is 3 plus J4. Okay, RL we have to calculate, that is variable. Okay, what should be the value of RL under this condition? Whenever you are having this format, RL is just the modulus value of the source ZS. Okay, so once if we take the modulus, then that is 5 ohm. So RL is 5 ohm. Okay, and again, what is the power maximum? P maximum is equal to I square R. Okay, so we consider that already this is in RMS. Okay, if that is the case, I can directly use this value. Okay, then first you find out I. What is I? I means voltage 100 divided by 8 plus J4. Okay, 8 plus J4 total impedance. Okay, now you'll get I. Okay, from that I you take just modulus. Okay, that value is 11.18 whole square. Then the R value is 5. So finally the answer is 625 watt. Okay, so this is the answer. Okay, so we'll end up with this. If you have any doubt, you can ask. Okay, so in the next session, if you are having any doubts, okay, you can share it in WhatsApp. Okay, we'll discuss. Okay, so the next session will start after 10 minutes. Okay, around okay 5:30. Okay, 5:30 to 6 o'clock. Okay, around half an hour we'll see, we'll discuss. Okay, if you have any doubt, see that. Okay, so